I want to go over exactly what the difference is between const and let, and honestly why you shouldn't care so much. Not that the differences don't matter, but the differences aren't that big of a deal. So I also want to clarify that var we are not talking about. Today in this video, we're only talking about const and let. So I wrote up some code examples that we can look at that I will hope will show you the differences between const and let. And the main one that you really want to focus on is const. Const is short for constant. And they're trying to say that things get locked down in a constant environment because it stays constant, because there's a lock. And really what the subtleness is about is what gets locked and where. And there are some concepts that you have to know to understand this. And you have to understand what a primitive is and what an object in JavaScript is. A primitive is the most simplest form of organism within the JavaScript ecosystem. It's just a string, a number, undefined, null, things that are as basic as possible, as uncomplex as possible. A string is just a set of text like a name, and a number is just a number. An object in JavaScript would be things like a function or an object literal. And const handles primitives and objects differently. So the first example I have up on the board is const being assigned to a primitive, which is my name, Drew. And you can see that const, let's see if I can draw this. Let's get a blue marker. So we have const account. Is equal to a string, which is a primitive. And you know it's a string because of the quotes. And you can even see on my text editor that it's all one color. And that's a clue. So let's just box this in. This is the primitive. And because it's const, that means that it's locked. Let's see if I can draw a little lock. All right. So when I go and I try to change it, and I say, oh, now I want account to equal a different string. And let's have that string of text be my girlfriend's name, D. Okay. And this won't work. This will give us an error, it'll say, but you use const. It'll scream at us. It says, but you use const, you lock this. Account can only be Drew. Account can't be D. Okay? So that won't work. And it's intentional, right? But if you use the let here, then it would be fine. Then it would work. Then account would equal D. But because you use const, it doesn't work. All right? So now that's an example of const and primitives. Now we're going to go and look at const in an application applied to a more complex object in JavaScript. And we're going to look at a very simple object in JavaScript called an object literal. Okay, let's clean this up. Now the thing about object literals in JavaScript is that they're more complex, like I said. They have an inside and an outside of sorts, which is important to what we're going to talk about. So the outside of an object, by the way, an object literal, all it's doing is having a bunch of key value pairs. So it looks like this, just in case you don't know. There is an outer bracket. This is the outer side, the outside crust of the object literal, like this. And you close it with another curly bracket. And then inside here, you have key, colon, values. And you can have as many of them as you want, right? So you could have a key of name, and the value could be a string of Drew or D. You could have a key of age and a value, have that be a number, and you can say, 28 or 26. So, key thing to note here is that the blue, this is the outer crust right here, right? And the inside is the properties, the key value pairs. Okay, so that's what an object literal is. And now we're going to see how it interacts when you use a variable with const. I'm going to bring up the code example I wrote earlier. Okay, so let's break this down. I know this is a lot to throw at you all at once, but we're going to dissect this piece by piece and have this all make sense to you. So, again, we just went over a primitive example where it was locked. Now here we're using const again, so you might assume that this object and its key value pairs might be locked as well. But there's a little bit of nuance involved here, which is exactly why I'm making this video. So we have a constant variable. Again, we have a count. And this can be anything, right? The count, you can make it anything. You could call that person, whatever, it doesn't matter. All right, and we're setting this equal to an object literal, just like I showed you before. Here's the outer bracket, and here's the closing bracket. And then inside here, we have the key, which is name, colon, and the value, which is Drew. And then another key, which is my age, and that's 28. This is a string, this is a number. And the computer knows that because there's quotes here around the string and no quotes around the number. So you can see up in the code that when you console log a count at this point, the first console log on line 5, you get the object literal. You get my name, Drew, and my age. Now the really interesting thing is that you can change this inner part, right? And down below we say account.name, which is this, account, and then the dot signifies that you go into the curly brackets, and then the name right here, the account.name, is equal to, now we're saying this is D. And you might expect that you won't be able to do that, but you can, as you'll see. And we're saying the account dot age is now 26. And when you console log on line 9, you can see that the object literal is now changed and the name is D with the age of 26. So const isn't locking the object, it would appear, right? At least it's not locking the green box. So technically, what's happening here is that it's locked to the outer scope, the crust, like I explained earlier. So this part right here, this outer part, is the part that's locked. If you were to go in and create another object, say, and you were to say const or no const, sorry. So you're just changing the variable account is equal to a new outer crust, and then it could be anything, right? You could say name Bob. This you're not allowed to do, because this right here is a different crust than this. So this is technically a new object, right? So you can't do it. The const variable only locks one level down. That's key. So let me see if I can draw this out in a different way to see if that makes sense. So let's use the pink one here. No, let's stick with the same color. Const, when you're dealing with a primitive, it only locks the first level, right? And a primitive only has one level. So a primitive, right? So for example, primitive would be a string, a number, undefined, you can keep going, null. So that first level. But const will lock the first level of an object. And that's basically everything else in JavaScript is an object. So we were using object literals, which is confusing because it's the same name, but it has literal at the end. You got functions. Right, keep in mind that we're only using this as an example for all other objects, because the same principle of const locking the first level is throughout, arrays, which are like lists of data. But whenever you go inside of the object, past the crust, it's unlocked. And you can actually modify the data in it. So it's the first assignment. All right. Let me see if I can hammer this home. Let's imagine that there are two objects floating around in your script, right? You got one object and you got another object. Right now these are empty, but you can even imagine it having data inside, right? You can imagine. But you see the outer and inner crust here. And the const variable can only point to one of the outer crusts, ever. It cannot be reassigned to this object, ever. You can only change what's inside in that green area. All right? But if this was let, then you can assign it to this object, right? That's fine. And then later on in your code, you can reassign this however you want. There's no locking. You can say later on, I want it to be over here. I want to just change its assignment to this object. And there'll be no problem with that. That's the difference between const and let. I hope you like this video. Let me see, is there anything else that I'm missing? I think that's really it, although I could give you a little bonus if you're still interested. The object in general, the first example I gave of an object literal looked something like this. Let's see, right? With key value. But really, these are two different steps if you think about it. You can also think about it like this. You can create an empty, completely empty object. No green key value, anything. It's completely empty, right? But that outer crust still exists. And then just like that code example up here, where actually you can even do it here, right? You're creating an empty object just like that, right? And when you console log that account, you're not getting this anymore, you're just getting an empty object like that. And then you can go in, and this is called account in this case, in both cases, right? And then you can say account.name equals D after you've already created the empty object. right? And is D. And I count, you get it, dot age. Right? Which is basically like inserting this into here after the fact. It's a two-step process, which is why there's this outer crust and inner property key value pairs. And the fact that these two can be separated is something to think about when dealing with consts. Thanks for watching. Hope you liked it. I hope this helped, and I'll see you next time.